All right, sorry about that. I got a phone call, of course, right in the middle of my video, because I forgot to put it in the do not disturb mode. So anyway, I'm gonna carry on where I was. Hopefully, it was on the every square inch of Earth has an absolute pressure of 14.7. I don't remember where I was going with that, but whatever. It's gonna be the 14.7. Anyway, well, let's move on to the next question here. Air systems only, or air system used only for heating require what compared to systems used for both heating and cooling? So out of the answers here, it's more airflow, less airflow, same airflow, or twice the airflow. Now, if you know anything about cooling, heating and cooling systems in residential especially, we're using a furnace and an A coil. The cooling actually requires more airflow. So an air system used only for heating is gonna require less airflow than one that's used for both heating and cooling. I don't know if you've ever seen a furnace in a house or paid attention to it. If it's a gas or oil or something like that, all the round supply runs that go to all the registers in the building are probably 5-inch. If you've ever seen a house that's done with a heat pump where they're doing heating and cooling, the round runs typically are 6-inch, just because they have more airflow in them. And one of the main reasons why you want to have more airflow is if you don't have enough airflow passing over that coil, it can tend to freeze up. So if a system is only heating, it's going to require less airflow than one that does both. Sorry, I don't know if you can see all these questions. There we go. So the last one here, forced air systems designed for cooling require about blank of airflow per ton of cooling. So this is kind of a rule of thumb that they use while sizing. You know, the proper way to size a house for heating or cooling is doing heat loss or heat gain calculations. Like in Canada, we're always doing heat loss calculations because typically we have throughout the 12 months, it's much colder than it is hot. So we care a lot more about the heating cycle than we do about the cooling cycle. So all walls and windows have an R value or a resistance to heat loss or heat gain. So if it's really cold outside, we want to try to keep the cold outside rather coming into our house. That's why we use insulation and stuff like that, and they all have an R value. And it works the same way if you lived in Texas, let's say, the insulation and stuff also has an R value, which is going to keep the heat out and keep the cool in your house. So in Canada, we do a heat loss calculation. So through windows and doors and stuff like that, especially, we're going to be losing heat. So as we heat our house, a certain number of BTUs are going to be, or British thermal units, are going to be escaping outside, which makes our heating systems less efficient. So we have to have a heating system that can produce at least the same amount of BTUs that's escaping our house. Usually you want to have one that does more than is escaping your house. You know, not too much more or else you're kind of wasting money, but you definitely don't want to have a furnace that can't keep up to the heat loss in your house. And again, it's the same if you were in Texas or whatever. You would want to make sure that your cooling system could keep up with the heat gain in your house versus the heat loss. So anyway, kind of rambling on. So the rule of thumb is that you have around 400 CFM per ton of cooling. So I'm not sure if you guys know yet, but like heat pumps themselves are like a 2-ton, 2.5-ton, 3-ton, you know, all the way up to 5-ton typically. So every ton of cooling there is approximately 400 CFM. So plus or minus 50. And then if you were sizing a furnace for a house, you're gonna have around 400 square feet per ton of cooling as well. So if I had a 800 square foot house, then I need a 2-ton furnace or heat pump. Hopefully that makes sense. All right, moving on. I'm only gonna do a couple more here because I'm gonna try to do a few of these every day so it doesn't get overwhelming for you guys and the videos aren't too long. Number 6 here, the total pressure loss in an air duct distribution system and its components, excluding the air handler, is called the what? Total pressure loss, so the options are total ductwork pressure loss, external static pressure loss, ductwork velocity pressure loss, internal static pressure loss. So it's this is kind of a hard one to explain, but if I have, I'm gonna draw another little picture here. If I have just a fan that is gonna be blowing air out, this fan by itself is gonna have a static pressure rating. If you guys actually might recognize it with a motor too. If I had a motor that was going to power this fan, a motor has a horsepower rating, and then it also has a brake horsepower rating. So the horsepower rating is what that motor can do all by itself. A brake horsepower is as soon as you put load onto that motor. So when you attach pulleys and all those things that put a load onto that motor, the brake horsepower is going to be less than just the horsepower by itself. So a fan all by itself with no ductwork attached to it has a static pressure rating that fan can overcome. And as soon as I put ductwork and stuff on that, and all the different components, registers and all that, it's putting a load on that fan. So that's called an external static pressure. So right here, the external static pressure loss, that's what they're talking about there. The total pressure loss in an air distribution system and its components, excluding the air handler, that's going to be the external static pressure loss. So hopefully that makes sense. Air systems with high sidewall or ceiling outlets normally are designed to, I explained this one in that video a little bit I did yesterday, but in a house, if I had a room and there was, let's say this is a window here, this is the ceiling up here, and this is the floor down here. So if I had a heat register in the ground versus a ceiling diffuser, just because hot air rises, if it's in the floor, it's more suited to heating. And because cold air tends to fall, a cooling system works slightly better if it's in the ceiling. So for this question here, a system with high sidewall, so if it was on the upper wall or in the ceiling, that's normally designed for cooling overheating, right? But if you remember what I said too before, hot goes to cold, so it really doesn't matter. Like this whole room is going to get heated or cooled regardless, just because of the laws of nature. I think I'm just going to leave it at that for now because, like I said, I don't want to overload you with too much stuff. There's the one I do tomorrow will be a little bit longer, I think, because there are quite a few questions on this test, and we are only here for this week. Yeah, so there's a total of 31 questions, so I only did 7 of them today, but it's a good start. Tomorrow I'll, do a bigger chunk. Anyway, if you have any questions, just ask me in class tomorrow.